In this video, I will be teaching you about the most used commands of RhinoCAD when it comes to designing guitar plans. For most of our processes, 2D will be sufficient. However, for a few guitar-related features, we will use some entry-level 3D drawing. In the next installment, we will use these commands, as well as some more specific ones, to put together a simple set of plans for a hardtail superstrat style guitar. For starters, we will be using one of Rhino's preset templates for creating drawings in inches. However, the process will be almost the same if you wish to use the metric system. When you first open your new project, you'll notice that you're presented with several views. Since RhinoCAD can handle full 3D, you're presented with 2D top-down, front, and right views. The perspective view allows you to better view your drawing in 3D when needed. In Rhino, there are multiple ways to select objects in a view. They have technical names, but I like to refer to the first one as Select Any Object My Selection Area Touches, which is a click and drag from right to left. If you wish to only select objects fully encompassed by your selection area, this can be achieved by a click and drag from left to right instead. To zoom, I prefer to use the scroll wheel on my mouse. To move the view, simply right-click and drag. However, in the perspective view, a right-click and drag will actually change the angle of perspective. To move around, you must hold the Shift key while doing this. For our purposes, we'll be using almost exclusively the top-down view, so we'll double-click that to make it full screen. You can get back to your other views by double-clicking that again at any time. First, let's look at the line command. Note, any command can be called by using the buttons, shown here on the left, or by typing the name of the command into the command line. As you type, Rhino will give you suggestions. Clicking enter will choose the topmost suggestion automatically. Rhino is really helpful once you've chosen your command, as it literally will walk you through the steps needed to use it. In the case of a line, it will ask you where you would like your line to start. You can do this by clicking on the coordinates you desire, or you're also welcome to type in the coordinates. However, remember that the coordinates you type in will be dependent on which view you're in. For example, here my 0, 0 expresses the starting point as the 0 position on my horizontal axis and then the 0 position on my vertical axis. To finish any step of a command, hit enter. Again, to do the next step, the end of your line, you can either enter your coordinates or click the desired location. Polylines are another fun one, as they allow you to string together multiple lines at once, which will automatically be created as a single object. The point command allows you to create points, great for referencing things later, as we'll see soon, anywhere on a grid. Here's a great example of left to right selection. You can see it only picked up my 2 points that it totally encompassed, but not the line that it merely touched. Unlike the right to left selection, which grabbed everything it touched. By holding Shift while making additional selections, either style or simply by clicking on a single object, I can add additional items to my selection. The delete command allows me to then delete anything I've selected. The rectangle command works similarly to the line command, but creates a box using the 2 coordinates that I've selected. This is also a great time to highlight that any button with a small drop-down arrow next to it has additional similar options if you click and hold. To explain this better, I'll choose the rounded rectangle and create a rectangle like before. But this time, I'm asked to perform a third step to define the radius of the corners. As usual, I can use grid clicks or the command line to finalize the step. Commands will generally create whatever you've asked them to as a single object. However, sometimes it's handy to break that object into pieces to manipulate it further. This is where the explode command comes in handy. Now, I have the major components of my rounded rectangle as individual pieces I can manipulate. The join command does the opposite of explode. Here I'll turn my rounded rectangle and 3 sides of my other rectangle into single objects. The click hold option isn't the only way to explore similar commands. For example, when I click a button like circle that has multiple options, I'll also be presented those options in a list where it assumes the topmost option as the default. For a circle, this will be to define a circle using the center point and the radius. But I can also define a circle by, say, choosing 3 points. Control A also allows me to select everything, handy here for a mass delete. As we move along, you'll start to see me move faster, so be sure to watch the command line for what I'm typing. Since guitars have a lot of graceful curves, the curve function will be used a lot. As always, there are many ways to define a curve, but we'll concentrate on the most graceful, in my opinion, the default control points curve. These curves will anchor to your start and end point, but all the other points in between will be used to pull the curve into its shape, e.g., they will rarely be on the curve itself. To modify these control points after creation, select your curve and use the points on command. From here, I can click and drag them to define my curve further. Hitting escape will hide the points again. Split allows me to cut objects using other objects. Here, we'll use a line to cut our curve into 2 objects by first selecting the objects we want to split, hitting enter, and then selecting the objects that we will use to make the cut. Trim is very similar, except it will also delete the split area that you click on. Everything we've done so far has used a function called grid snap. This means that my clicks on the grid have automatically anchored to the nearest 1/4 of an inch, or whatever grid values your template has set or has been changed to if you're more advanced. Turning off grid snap will allow me to anchor to any location on the grid. Ortho is a similar function that requires your snaps to be at 90 degrees to previous snaps. We'll show how this works using the line function. However, I find it's easier to leave ortho off all the time and simply hold the shift key when I want to turn it on momentarily. Rhino also offers you a number of intelligent ways to snap to other objects instead of to the grid. You can select any number of them by using the checkbox next to the desired snaps. Here, I've turned them all off, so you'll see I'm only snapping to the grid still. But once I turn them on, you'll see that the grid snap is overridden by these object snaps. It's also handy in that it tells you which, singular or plural, object snaps it's using at any given moment. These are the ones I like to keep on. Smart Track is a special edition here in that it allows you to hover over an object snap point till it turns gray, and then reference it nearby. This is what you saw earlier while I was playing with snaps and Rhino was drawing gray lines on the grid with labels like on ortho or on perp. The move command allows you to shift the location of objects by selecting a starting point and an ending point. Here, let's move this back using an object snap to the middle of our line. Note, your 2 reference points do not have to be on the objects. Let's join our leftovers and play with the scale command. The first point will be the so-called center of where you scale out from. The second will be your reference for the current scale. And the third step will define how large the distance between those first 2 points should be at the end. Again, you can define this by clicks, or here I'll say I want to make this 5 inches long for my third step. Let's try that again, but freehand. Notice, having my center and reference points off the object really highlights what I mean by having the object scale out from the center point. Notice here that the object not only scales, but also moves due to this method of scaling. So far we've scaled in 2D, or in layman's terms, the object has been scaled in proportion. But I can also scale 1D as well. Here we'll scale just the x-axis. And now, scale 1D again to make things match up using object snaps. Rotate allows us to rotate objects around a center anchor by choosing the central point and a reference point. Again, neither of these points need be on the object itself. Let's draw some stuff and switch back to our multiple views to see what rotating is like in 3D. As you can see, the view I use will define which axis is used for the rotation. Lastly, let's see a sneak peek of what Rhino can do in 3D with the Sweep 1 command. Here, we'll select a rail and cross-section curves, plural if desired, to sweep to create a surface. We won't get into the nitty-gritty of all the details of sweeps here though, as generally for our purposes, the initial suggestion will work just fine. Right-clicking on our view name will allow us to change the way the objects are displayed. For instance, to better see the surface, we'll choose Rendered.